Now that we've cleaned up that other request handler, we can start to implement some caching logic inside this exec function that we overwrote right here. The first thing we need to do is think again about our cache key that we're going to use inside of Redis. Now, as a reminder, we had spoken a little bit ago about how we need to figure out some more unique and consistent cache key that will not somehow collide with other collections that we introduce in the future. We had spoken about the presence of a getQuery function. That getQuery function took a query and returned inside of one single JavaScript object all the different ways that that object, or that query, had been customized. So let's now kind of get a more working knowledge of how that getQuery function works. So back inside my code editor, directly underneath that console log that we already have, I'm going to add on one other console log. And inside there, I'm going to run this.getQuery. Now, one quick thing here. Notice how I'm making reference to this. This right here is a reference to the current query that we are trying to execute. So in any way, or like if we think back over to the blog routes file over here, we had made this query right here, and then we eventually executed it. So in this case, if we ran this.getQuery, I would expect to get back an object telling us that we are trying to find a user with some particular ID, because that is the way in which this query right here had been customized. So I'm going to save this file with the console log. I'm going to go back over to my browser and refresh the page. And then we'll check our terminal and see what the result of that console log was. Okay, so I just refreshed it. And now back over here, you'll notice I'm about to run a query, and then it has some information about how that query was customized. You'll notice that these first two console logs are completely identical, and that actually is to be expected. The first console log that you see right here is a request from our React application to get a reference to the current user who is signed into the application. So this query right here is to get the current user of the app. The second request that you see right here is also to get the current user, but it's in the context of making sure that whoever's trying to fetch the current list of blog posts is actually signed into the application. So these are two queries that are completely identical. They're both trying to get details about the current user, but they're being executed at different locations inside of our project. These right here are great examples of calls that we would definitely want to eventually cache inside of our app. You'll then notice that the third query right here is the query that's used to actually fetch our list of books, or our list of blogs that belong to the current user. So we're specifying _user, and then the ID of the current user that we want to fetch all blogs for. So this is an example of the getQuery function in action. Now, one other thing here related to generating our more robust cache key, you'll recall that we had said that the cache keys here were supposed to be like our query, right? We were going to take the query and use that as the actual key. We had also said that these needed to be consistent and unique. So by just calling getQuery, that's definitely enough to identify a query that's being issued in multiple copies of it in a row, as we're seeing right here, right? These are consistent query calls. However, we're still not encoding in the actual name of the collection that we're trying to make the query over. So even though these are clearly different IDs right here, we might eventually be trying to issue queries that are identical in all respects except for the collection that they're being executed over. And so we would need to make sure that we somehow also encode the collection name into the key as well. So to get access to the collection name, we can console log out this.mongoose collection.name, like so. So let's save this file and run this inside the browser again. So I'll refresh the page. And then over inside my terminal, now we'll see those query options right here. And then right underneath it, you'll see the actual collection name. So if we combine together the query options and the collection name, we will in fact end up with a cache key that is both unique against other types of queries that are being issued, but also consistent to make sure that if this same query is executed again, it'll recognize or it'll produce the exact same key. For example, again, these two requests right here are fetching the current user. And if we combine this object together with this string and this object with this string, those two keys would be absolutely consistent. So the same exact query yields the same key, but they are different compared to this other query over here. So again, unique but consistent. Okay, so now the last thing I want to show you is how we're going to actually combine those two pieces of information to generate one single key. Okay, so this is the same diagram that we were looking at just a second ago, but I've now taken the key and actually placed it in here. So we're going to take that object that we just saw, like the result of get query. We're going to add in the collection name as a simple like collection property, like so. We're then going to take that entire object and we're going to turn it to a string, and then we're going to use that entire string as the key inside of Redis. So that's how we're going to end up with a key that is both consistent and unique. Okay, so that's the plan. We're going to combine that object, that get query object, together with the collection name and then use it as the key. So let's take a pause right here and we'll write out the actual code for that in the next video.